spring light falls into winter night.
Welcome to Simplifying Algebraic Fractions. Before we get started with simplifying algebraic fractions, let's just back up a little and review how to simplify fractions. I know that this is pretty much common sense, but if you really think about the process, when we go back to simplifying fractions, the process really involves factoring, canceling out the common factors to simplify the fraction. So they both have a common factor of 5. When we cancel out that common factor, we're left with 3/4, which have no common factors. So hint, hint, what we've been doing for the last week will not go without use. What exactly is an algebraic fraction? It is the quotient of polynomials. And in some cases we're using that word liberally, polynomials, because this in fact isn't really a polynomial because it involves a negative exponent. To be in simplest form, an algebraic fraction has to have no common factors other than 1 or -1 in the numerator or the denominator. The steps for simplifying algebraic fractions. The first step is to basically factor completely both the numerator and the denominator. Once we've done that, we can divide the numerator and the denominator by their GCF, and we will cancel out any and all common factors. Now there are some tips I'd like to add. One is you can always use the commutative property of addition or multiplication to your advantage, but beware you cannot use the commutative property for subtraction or obviously for division. And we'll see how that works in a little bit. This is another key component that we have discussed a little bit. I think it came up last week. Variables and numbers separated by a plus or a minus can only be canceled as a group. So if you think about 2 times 3 and 2 times 4, sure, I can cancel out the common factors of 2 and get 3/4. But 2 plus 3 and 2 plus 4, this is going to be 5, 6, which is not the same as 3/4, right? We can only cancel if expressions are linked by multiplication. We're going to take a look at a really simple case that you could have done by the rules of exponents, but we're just going to apply the factorization so we can see the process. If I break this fraction down into its prime components, I can see that I have a 5 in common and 2 x's in common, and that would give me 3/7x squared. Now we already knew that, but we're just showing how the method works. Go ahead and try the second one and see what you get. I got 2ab. Now as we move forward, we're going to factor, and it's going to become maybe a little different. Let's look at number 3. If I factor number 3, I get 4 is the common factor in the numerator over 2y. Now I can cancel the common factor of 2 into 4 2 times, and my final answer is going to be 2 times the quantity y minus 2 over y. If you think that's pretty easy, you can go ahead and work on the next few. I'm going to do one more that you can stay with me if you'd like to see it worked out. Let's take a look at number 5. I can factor in 8x out of the numerator, and then I'm going to have x plus 5, and then I have an 8x in the denominator, so that's going to just give me x plus 5 as the answer. Go ahead and finish the rest on your own. I have the answers for the remainder, and hopefully you did well with that, and we're going to continue on and do some more complex problems. The one thing I want to remind you is you have to factor first. Just like when we were factoring and I said look for a GCF first, the same process here. And as we go forward with multiplying, dividing, everything with algebraic fractions, you're going to have to keep this in mind. So this one is not in your notes, but let's take a look at this together. X squared minus 36. Your friend and mine, that's going to be difference of 2 perfect squares, x plus 6 times x minus 6. In the denominator, I have a very friendly trinomial, and we should be able to factor that relatively quickly into x plus 6 and x minus 5. So I can cancel factors that are a group with another group. These guys I cannot do anything with, so my final answer is x minus 6 over x minus 5. Get the hang of it? Let's try another one. What I'm going to do here is pick one of the more complicated ones, and I'm going to let you guys work on the others. We will come back and do 11 through 14 because that's a special circumstance. Let's take a look maybe at number 8. You should factor both the numerator and the denominator, and hopefully you have a y there and not an x, but if you don't have an x, change it to a y. In the numerator, I'm going to get, I hope you factored that on your own, y minus 3 and y plus 7. In the denominator, I get y plus 7 and y minus 7. So all of those groups are connected by multiplication, so I can cancel those out, and then I'm left with y minus 3 over y minus 7. Final answer. Try 7, 9, and 10 on your own, and then come back and we'll do a little work with 11 through 14. Here are the answers for 7, 9, and 10. If you have remaining questions, make a note of those and we'll address them tomorrow. Now let's take a look at the special circumstance. This is really important because it helps you to reduce where it looks like you might not be able to. In other words, I can factor out a -1, in this case from the numerator or the denominator, whichever I choose, and that is going to allow me to flip the x minus 3 to a 3 minus x. Therefore, I can cancel these, and my final answer here is just going to be -1. Kind of snazzy, huh? Let's try another one. We'll go to number 12. I know in the denominator it's our lovely friend, difference of two perfect squares, b plus 3 and b minus 3. And I think, oh, I wish I just had a b minus 3 in the numerator, then my life would be so much better. And our friend -1 comes along, and he's like the knight on the white horse, comes galloping into the room and says, "Let me help you, lassie." And so we get b minus 3. Then I can cancel away, and my final answer is -1 over b plus 3. Want to try the next two on your own? Go for it. For number 13, I got -1/4, and for number 14, I got -1 times the quantity 4 plus a over 2. Now there could be variations of that, and we can talk about those tomorrow if you want to check what you got there. So hopefully you're doing well with this, and we'll get more practice tomorrow. Have a great night.